Hello everyone. In this video we're going to create a custom computer vision application using Groundlight AI. Groundlight can answer natural language questions about images. Any question you can think of that could reasonably be answered by a person can be answered by Groundlight. For example, is the door open? Are the screws completely screwed into the part? Or is the white truck in the loading dock? Groundlight is used for many things, including facilities monitoring, industrial automation, and robotic inspections, to name a few. It's also available in a user-friendly Python SDK, which we'll use today. With just a few lines of code, we'll have a working program that answers natural language questions about images. And the best part is, because of Groundlight's escalation technology, there's no need to prepare a dataset first, and your program's accuracy will actually increase over time as it runs, even as the scene changes. In future videos, we'll explore some more complex applications like deploying Groundlight on a Raspberry Pi, a surveillance camera, or even on a robot. Okay, so the first thing I'd like to do is create a directory where we can keep all the files for this project. So I'm just going to call this folder gl_sample. We're going to go into that folder. And then before we install anything or create any files, I'd like to create a virtual environment where we can keep all of our dependencies for this project so we don't have any conflicts with other things that we might have installed on our system. So to create that environment, let's run python 3-m venv, and then we need to provide the name of our environment. I'm just going to do gl_env, and that will create our virtual environment. Okay, now we need to activate the environment, and this can be a little bit different depending on which operating system you're on. In Windows PowerShell, you'll do gl_env scripts activate. Now you can see it's active. If we want to get out of it, we can just write deactivate, but we'll stay in it for right now. Okay, now we can start installing things. Let's run pip install Groundlight to get the Groundlight Python SDK. Okay, the next thing I'd like to get is a library called FrameGrab. FrameGrab is an open source Python library that Groundlight provides and makes it easy to use different types of cameras in your applications, whether it's a USB camera, a high-end industrial camera, or a network camera. All right, so that's all the dependencies that we need for our project. Okay, next we need to go retrieve our API token from our Groundlight account. So go to groundlight.ai, click login, and here just log into your account, or you can sign up for a free account if you need to. Okay, once you're logged in, go up to the top menu and select API tokens, create a new token. Okay, you're going to want to hang on to this API token in a secure manner. I recommend putting it into your favorite password manager. Whatever you do, do not commit this to GitHub, especially if it's a public repo. This is a credential, so you want to keep it secret. Okay, so we're back in the terminal, and I'm going to take that API token that we generated and set it as an environment variable so that we can use it. This is another one of those things that's different depending on which operating system you're using. I'm going to show you how to do it here in PowerShell, but on the screen we'll put the commands you can run for Mac or Linux. Okay, now it's time to start writing our program, so go ahead and open up your favorite IDE. I'm going to open VS Code, and I'm going to create a file called main.py. And we'll do some imports. Okay. Next, we want to instantiate the Groundlight client, and we'll do that by, well, we'll call it gl equals, and then we'll do groundlight.groundlight, and that's it. So the way this works is it will read from the environment variables to find the API token. You can also pass in the API token into this object, but it's usually better just to have it in your environment variables. Okay, next we need to set up our detector. I'm going to create one today that simply asks, is the trash can overflowing? And we'll have it check my trash can and let me know when it needs to be emptied. You don't have to do this. You can come up with another question, whatever makes sense for your environment. If you want to do something really simple, you can just say, is the person giving a thumbs up? That's always an easy one, although not that interesting. But just pick your own question. So the first thing we need to do is actually give our detector a name. And I'll just call mine trash detector. Next, we need to come up with a detector query. And this needs to be a full sentence that any human being could read and understand and answer accurately. So for mine, it will be, is the trash can overflowing? And remember, Groundlight will escalate these queries to humans in the cloud when necessary. So it's very important that these questions are easy to understand. Okay, next, to actually create the detector, we're going to call it detector, and we'll run gl.get or create detector. And we'll pass it our detector name and detector query. Okay, next we need to set up our camera so we can get some frames. And again, we're going to use frame grab for that. So we'll call our camera grabber, and we'll create it with framegrabber.autodiscover. Okay, so this function will actually return a dictionary of grabbers where the key is the name of the camera and then the value is the actual grabber object. And in this case, we just want to get one grabber out. So what we need to do is get the values, turn this whole thing into a list, and then select the one that we want. And then depending on how many cameras you have connected to your computer, you might need to adjust this number to find the one that you want. Okay, so next I'd like to get a simple video loop going just to make sure that we can get frames from our camera. So we're going to do grabber.grab, and that gives us our frame. And then we're going to use OpenCV to show that frame. We'll call the window video feed, and we'll put the frame onto it. And then we're going to wait a bit. Let's just say 30 milliseconds. And then at the end of this loop, we're going to put some cleanup operations. So first we're going to have grabber.release, and we're going to destroy all the windows. All right, so that should continuously grab frames in a loop and show them to us. So let's go to our terminal and run our script. And we can see a live stream of my trash can right now. Let's just make sure that it's actually live. All right, so it is live, and you'll notice in your terminal here there are some errors from OpenCV. This is nothing to worry about. This is basically frame grab trying to connect to all the different available cameras, and it gets an error when it tries one that's not available. Okay, so next I'd like to add some controls to our program. First of all, so that we can stop the program when we're done. And then, of course, we also need a way to submit an image query to Groundlight. So we're going to use some of the built-in functions of OpenCV to handle key presses. All right, so first of all, if we press the Q key while the OpenCV window is selected, that's going to exit the program for us and clean things up. Okay, then if you press the Enter key on your keyboard, and we're checking for a few different types of carriage returns, then that will be the signal to submit the image query to Groundlight. Okay, so let's start by just printing out what we're doing. Okay, then we actually need to submit the image query to Groundlight. All right, so there's a lot of different parameters you can pass in here. The two required ones, of course, are the detector that we're sending this to and the image. And I'm not going to talk about any of the other parameters today yet because we don't really need them if we just want to do a simple example. All right, so this will be a blocking call to Groundlight to get an answer, and then when it's done, let's print it out. Okay, let's run that and see how it does. Okay, so our program has started. Let's select the window and press enter. And you'll see that we're asking Groundlight, is the trash can overflowing? So this is the first time we've ever asked this question. Groundlight doesn't know yet, so this will almost certainly escalate to a person, and that person has responded and says no. So let's do another one. Okay, and we got another no. So the more we do this, the more labels we have in our model, and this will become faster and more accurate over time. But of course, we need to give it some yes labels too. So I'm going to walk over to my trash can and stuff some trash in there, and we'll submit that. Okay, let's send that to Groundlight. Okay, and we got a yes, so that's great, but let's give it a few different examples of what yes looks like. We got another yes. Let's do one more. And we got another yes. So that's basically how you submit image queries to Groundlight. Next, I'm going to show you a more efficient way of submitting labels to Groundlight, which can be especially useful when you're getting started and you just want to very quickly send a bunch of yes and no examples. Okay, so now let's just comment out what we did there to submit image queries, and we're going to do something a little bit different to submit a label. All right, so I'm going to check for key presses again, and we're going to see if the Y or N key was pressed. Y is going to be a yes label, and N will be no. Okay, so if we receive one of those key presses, we're going to submit a label. But we're going to check here which key specifically was pressed. So if it was the Y key, we're going to set the label equal to yes. Otherwise, no. All right, so now we're going to submit an image query again, but a little bit differently this time. We're going to use a method called askAsync, and that essentially sends the image query off to Groundlight, but does not wait for the answer. And we're going to follow that up by sending our own label to the image query. And you'll notice that I passed in an argument here that says human review equals never. So this will never be escalated to a person because in this case, we don't want that. We're going to provide our own label. And to add our own label, we're simply going to do gl.addLabel. Okay, and that's all there is to it. Let's go ahead and print out what we're doing so that we can understand that when we're running our program. Okay, so our program is running now. Let's add a few labels. So it's obviously overflowing now, so I'm going to hit the Y key. And we've added a yes label. And we can do this a bunch of times. But really, we should be changing the scene a little bit to give some better labels. So let's do that. Okay, so we've given several yes labels. Let's do a few no labels. All right, that should be enough data to get our detector started. All right, so the last thing I want to do today is to put this into a timed loop so it periodically sends image queries to Groundlight. And then we can even get it to send notifications to us when there's an anomaly. So again, I'm just going to comment out that bit of code that we added for labeling. And now I want kind of a timing mechanism to happen here in the loop. So first we're going to define a wait time in seconds. I'm going to do this as 5 seconds for now. This is probably way too fast for like a final application, depending on what you're trying to do. But for development, we're going to have that at 5 seconds. If you're actually going to leave this on for a long time, you might want to make that a longer wait time. Okay, then we're going to define another variable which we'll call last capture time. And this is the time that we last captured an image and sent it to Groundlight. And to initialize it, we'll just do the current time minus the wait time. So in other words, for the first iteration of this loop, it's going to be time to submit an image query to Groundlight. And then we'll wait 5 seconds after that. Okay, so here's how it's going to work. We're going to check the current time here in the loop. And then we're going to say if the last capture time plus wait time. In other words, it's time to take another picture. We're going to say last capture time equals now. And then we're going to do some of the stuff that we did before. So we're going to print that we're submitting an image query. We're going to submit the image query and get the answer. And then I guess that's about it. Maybe we'll print that we're waiting. Okay, that looks pretty good to me. Let's go ahead and run the program. All right, so our program is running. You can see that it's asking the question. Our detector is still pretty new, so this has probably escalated. We're going to get a human answer in a few seconds. Okay, there's our answer. No, it's going to wait 5 seconds and then go again. All right, so the loop is working. So now I'm going to show how you can set up some alerts for your image queries. And of course, you could do this in your Python script with whatever alerting mechanism you'd like, but there are some built into Groundlight. I'm going to show you those now. So go up to Outputs, click Create a new Groundlight action, and then first we're just going to give it a name. Let's call it Trash Overflowing. And then you're going to choose your detector, and there's a bunch of options here for how you want the logic to work. In this case, I'm going to say if I get 2 consecutive yes labels, we're going to send a text message to my phone. And then just to make sure that you don't get bombarded with notifications, you can have it snooze after a period of time. All right, so that notification is now set up and we can get those on our phone. Now you've seen the basics of using the Groundlight Python SDK. It was a pretty simple example, but I think you can see how easy it would be to integrate this into a more complex program. In future videos, we're going to show some more complicated examples, so stay tuned for those.